makers of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and sitting in for Gary Kildall this week is Herb Lechner. We're talking about printers on today's program, and I guess most computer users have found that a computer alone really doesn't do you very much good unless you have an output device on which you can save data, graphics, program listings on a good old-fashioned piece of paper. Now, Herb, it seems, though, that printer technology has lagged behind computer technology in general. The printer is still the slowest component in the system. The price really hasn't come down that much, and it's often the first part of the system to break down. Why is that?
I think, Stewart, the answer to that is the fact that there have not been the breakthroughs in the mechanical components of printers that there have in the electronic areas. And I believe that both users and manufacturers alike are well aware of that and are trying to become less dependent upon the purely mechanical functioning of printers and trying to develop electronic controlled components, examples of which we will have on our show today, the inkjet printer and the laser printer, instead of mechanical impact technologies.
Okay, before we take a look at the latest in printer technology, let's briefly review the history of printer technology.
When Charles Hollerith introduced his census-taking machine in 1890, it had one important task: to collect and tabulate large numbers more efficiently than the humans it replaced. Like other early computers, its electromechanical memory was limited, and printout of stored information was restricted to the final computation. As computers became less mechanical and more electronic, information retrieval became more flexible. Once magnetically encoded onto a reel of tape, data could be changed or erased instantly, and the recording medium used over again. Printed information, or hard copy, was unnecessary as long as data was used only within the functions of the machine. Information gathering became even more perishable when video display terminals became standard, reproducing text, graphics, and even mimicking the physical surroundings of a workplace. But today, while computers may have reduced the need to stockpile written information, a quick look at the typical office reveals that one of the most common peripherals is, ironically, the printer. Popular impact printers like this daisy wheel still operate much like a typewriter, but with fewer moving parts and much greater speed. Although advances in printer technology have not matched the progress made on the electronic side, the trend away from mechanical complexity has brought paper and ink printing to a new level of sophistication. The focus of new research is on non-impact printers, using heat, electricity, phototypesetting, or even lasers that burn characters into the paper.
Later on, we're going to be taking a look at the cutting edge of printer technology, laser printers being developed now by Xerox. First of all, we want to talk, though, about the kinds of printers that are available for most computer users. And with us to do that are two gentlemen from the Diablo printer division of Xerox. We have Steve Ray, who's a systems engineer with Diablo, and Paul Shapiro, who is the manager of product planning. Herb?
Gentlemen, maybe you could get us started by taking the various numbers and different kinds of printers that are available today and sort of categorizing them for us so we know what we're talking about.
Okay, well, most generally there are, you could classify printers as either non-impact or impact technologies, and within each of those you could, I guess, semi-classify them as what kinds of technologies they employ to put marks on paper. For example, there's matrix within impact and inkjet within non-impact. Within that, there's various cost performance ranges, and then, of course, you'd always have to consider the quality of the print, which is spot density.
How does a user try to figure out which printer is right for him? And we've got 3 printers sitting here, and that doesn't even begin to represent the variety out there. How do you make a determination as to what printer a particular user should buy?
Steve?
I think what you'd like to do is, with the explosion of the PCs, the personal computers in the marketplace today, categorize it as if you want to have an impact type printing, very hard copy that's good for letters and mailers or that sort of thing. And then, of course, for very high speed output, you might want to go into a thermal type technology, which is thermal transfer to plain paper. And then, of course, if you really wanted to go for with all the color output that people have now, you go for a color inkjet, and here we have a Type 3 color inkjet today.
How about, say, the first tier, say, I'm choosing between a dot matrix impact printer and a daisy wheel impact printer. How do I make my determination, say, just choosing between those two?
Well, it depends on the quality of output that you're looking for in a particular product, as well as the kind of speed of output. If I were, for example, looking for fully formed characters, a letter quality output, I would gravitate towards a daisy wheel printer, which tends to give you the best quality possible. If you're looking for a very high-speed type of output with less than letter quality, called correspondence quality or draft quality, a dot matrix printer might be the way to go.
Where does the thermal printer fit into this?
I'd say for very high-speed output, our thermal printer here that we have today runs at 6 pages per minute, typically, which is quite fast compared to, say, a daisy wheel, which would be slower, maybe a page, 2 pages per minute. And then for inkjet, we run even slower, but of course we're working with color in this case.
Maybe we could demonstrate at least the first two you have at the top there, Steve, because it'd be interesting to sense the speed comparison you're talking about. Maybe
Sure.
you could fire up your daisy wheel and let's see, number one, how much noise it makes, and number two, how fast it goes.
Okay.
And maybe you can talk us through it as you do it.
What we're showing here today is a daisy wheel that's been out in the marketplace for many years. In the early 70s, it was in fact firstly introduced by Diablo Systems, as a matter of fact. What we have is a character print wheel here with 192 fully formed characters on it, so that you can do scientific notation, and we also have other application print wheels for a legal market, or actually even moving into, say, a multi-purpose market where you want to do sort of European-type applications. With one print wheel, we can print 33 Western European languages with never changing that print element, and that is in fully formed character.
We see two trends in the daisy wheel printing technology. The first one is to larger numbers of characters per print wheel, and here we have 192. We also see the growth of accessorization, and you're actually seeing a electronic double bin feeder. This is a very throughput-oriented kind of trend for the market, to increase the amount of throughput per any amount of time.
Maybe we can look at your thermal now. I think everybody's aware how much noise the daisy wheel makes, which is a factor, I suppose, if you're trying to place it in an office environment.
Sure.
What speed, by the way, did that daisy wheel operate at?
About 40 characters per second is what we can specify for what we call a AAA type text. The thermal printer is much quieter, 55 dBA. As far as cost-wise, it would be more expensive, of course, because you are getting that extra speed out of it.
In the area of cost performance, the thermal transfer machine, the machine that you see printing right here, it runs at about 6 pages per minute as opposed to 2, and yet the price is only about twice the price of a daisy wheel printer. In terms of spots per inch, the thermal transfer machine is about a little less dense than a daisy wheel, which runs at about 450 spots per inch as opposed to the 200 spots per inch that you see here.
I guess that sort of leads us then into the new technology, the color and the graphics technology. How is the market moving for that kind of a device now?
As graphics become and color becomes a more important part of the PC user, the market tends to be gravitating a great deal towards graphics and color, especially with those processors like the Apple Lisa and that are able to do bitmap graphics, that is, control each and every bit on a tube, each and every bit on a page. The thermal transfer machine, which has a great ability to do graphics, as well as the inkjet, as a color graphics, is a natural migration.
How do we interface these printers with a computer? Say we have a computer and we want to go about knowing that we can get some of these capabilities, but wanting to be sure that we buy something where the plug fits.
What we've done at Diablo is we've tried to answer that in what we call all-purpose interfaces, something that you can just take a personal computer, because typically your end user will just want to have something which we call plug and play. You take your personal computer, you take your data cable, and you plug it in. What we've done is we think we've been rather innovative in the way of being able to run parallel or serial machines off of a host processor, so it becomes very, very user-friendly in that case.
We have just a little bit of time left.
Sure.
Maybe you could fire up your inkjet printer and also tell us how that works.
Sure. What we specify for this, well, what we're saying is a Series C color inkjet is a Type 3 inkjet, which is a drop-on-demand. That differs from a continuous flow in the fact that we're able to actually, as Paul mentioned, specify where on the paper you want to put the dot, and through an ink reservoir, through a piezoelectric type electronic means, squirt a drop per nozzle onto the paper.
How fast are the squirts?
It goes about 20 characters per second for text. We do have the ability in having 4 colors on here to generate, through doing mixing, to generate 7 colors, and actually 8 if you include white as a color. Very quiet. It's very nice for having it next to a single workstation.
What is the cost factor of the inkjet compared to the others?
The inkjet is slightly less expensive than a fully formed character printer here, and I guess compared to the thermal transfer, which quite frankly has 5 times the throughput or 6 times the throughput of an inkjet, it's about 1/5 the cost. 1/5.
One last question. On the thermal, don't you have some built-in limitations there? You need special paper, you can't do multiple copies, you can't use fan fold and so on?
Actually, that's only partially correct. The thermal is able to use a bond paper here. Depending on the rag content, of course, gives you the greater quality and output. Fan folded is not necessary. You can use, as you can see, we're using cut sheet feeding here, cut sheet paper, and so the nice thing about the thermal transfer as opposed to the direct thermal, which you're probably familiar with, is that it's able to use plain bond paper, which is a very nice characteristic of this new technology.
Okay, that's a real brief introduction, Steve Ray and Paul Shapiro, and I thank you very much for introducing us to these 3 basic types of printers. And in just a moment, we're going to take a look at the latest in printing technology, laser printing, and that's coming up next.
We have been told that one of the characterizations or categorizations of printers are their speed. To talk about a very fast printer technology, we have with us Dr. John Urbach from Xerox Palo Alto Research Center to talk about laser printers. John, can you tell us in general terms how a laser printer operates?
Well, a laser printer operates in a manner that is somewhat analogous to the way a television system operates. Only in this case, a finely focused beam of light from a laser is scanned across a line. It is turned on and off at a very high rate by what we call a modulator, and this paints out regions of illumination or lack of illumination along the scan line. The scan line can then be repeated over and over again, and some kind of a light-sensitive recording medium is moved along underneath the scan line, thus generating a raster image, a 2-dimensional raster image, quite analogous to the kind that we had seen there from the inkjet printer. The difference, however, is that it goes very much faster and at very much higher resolution than this type of inkjet printer.
Typically, how fast in terms of lines or pages is a laser printer?
Yes, we're more comfortable talking about pages than lines because the great flexibility in character size that you have with these printers makes it hard to describe accurately in terms of lines. So in terms of pages, they vary from a high of perhaps 3 pages per second down to on the order of 10 pages per minute. They cover a fairly large range of speed.
Yes. You mentioned flexibility. What do you mean by flexibility in a laser printer?
Well, since you can paint out every possible resolution element on the page, exactly as you can in a television system, you have the ability to create a completely arbitrary map of any type of image information that your computer can generate. Most computers can't generate information in a manner flexible enough to take advantage of the capability of a laser printer. But if the computer can generate the image, then within some very broad limits, the laser printer can generate.
Anything you can compute, you can print, so to speak.
Right.
Well, you are prepared to give us a demonstration of a laser printer today. Would you like to describe what we will be seeing, please?
Yes. Remember the basic principle which we can see on this figure is that the light from the laser goes through a modulator which switches it on and off very rapidly, and then through a scanning system of which, in our case, a rotating polygon of this type is the heart. The rotating polygon has a large number of facets, of mirrored facets on it, and that is what actually deflects the light to generate the scan line. That scan line is then focused by a fixed optical system onto the photoreceptor. In our case, the photoreceptor is from a conventional xerographic copying machine. And instead of making a copy of some original, that photoreceptor now records the image that has been generated by the computer. Now, in the particular demonstration that we'll see, we have an experimental color laser printer. These are relatively rare, but they are an illustration of the power.
This is not a standard product.
No, there are such products available, but they're not widely used yet.
Okay, now let's go to see the demonstration. Stewart?
This is Doug Curry, systems engineer with Xerox. And Doug, you have a file in memory now of a graphic of a baboon, which we're going to use for demonstration purposes here. I want you to show me what control you have here at the computer terminal over the parameters that we're going to use in printing this out.
Yes, Stewart. When we print a color file, we do so by superimposing 3 separate images of magenta, yellow, and cyan. Now, what I've done here is I've brought the magenta layer up onto the display so that we can modify some of the color intensity distributions. Now, for instance, I can take the mouse and point to various places on the baboon and find out what the pixel intensity is at that location. I can then go down to the tone reproduction curve and modify it with the use of the mouse. For instance, if I want a more contrast in my output, I can make a slightly nonlinear function for my drawing. And I can modify it by clicking the mouse button, and then I can show the modified version. And I can flash back and forth to find out whether or not that is what I really want. And what I'm going to do now is to actually print out the 3 separate layers, and then after that I'll print out the final full color image.
This is Tibor Fischli, manager of printer technology at Xerox. And Tibor, explain to me now that we're printing, what's going on inside the printer?
Now the information is coming from the computer, and that video is used to modulate the scanning beam, which in turn lays down the image on the photoreceptor drum, one by one, color by color. And actually, the xerographic process does not really know or care where the light is coming for the exposure and initiating the whole process.
And what do we have then coming out of the machine?
Now we have a full color picture of the baboon.
Tibor, that graphic is pretty impressive coming out of this printer. Can you show me now a demonstration of what the device is inside the printer that's doing it?
Yes. This laser printer is identical to the one which was used for the demonstration. I would like to now tell you the major component and describe the optical path. The beam from this helium neon laser is folded and focused into this acousto-optical modulator. The diverging beam from the modulator is folded along the optical path into the polygon, and after reflection from the polygon is coming back through the same element, and it folded and focused on the surface of the photoreceptor, which is not here represented by this white screen.
Could you actually show us the laser beam inside here?
Yes, I will spray some Freon. It would make the light path visible. You can see how it's coming out from the laser, going through the modulator, into the folding optics, and into the polygon.
That was a very interesting demonstration, John. Now can you sort of talk to us about the future of laser printing technology? Are there going to be more laser printers? Are they going to come down in price? Will they displace other printer technologies that we've talked about today?
I think, Herb, the answer is yes to all of those questions. There will be more laser printers, and they will come down in price. The early laser printers were very fast, but also very expensive machines, costing hundreds of thousands of dollars. The price is now rapidly coming down, helped in some of the future products and some recently introduced ones by the use of the junction diode laser, this little gadget I have here, which will replace the large helium neon laser and the modulator, reducing both size and cost of future printers. And with this and other refinements, we'll see the price coming down quite rapidly over the next few years.
So naturally, you're enthusiastic about the future of this technology and its ability to do the text processing and the graphics processing that we talked about earlier.
Yes, I am, and I also believe that by increasing the resolution, as in this experimental machine, we can also move toward high-resolution graphics and pictorials.
I'm afraid we're out of time for this session of Computer Chronicles. Thank you very much, and we will see you on our session next week.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.